Hi, everyone, and welcome to Lesson 4 in our AI series. In Lesson 1, we explored what AI is. In Lesson 2, we learned how AI can be trained with images. In Lesson 3, we talked about why AI can sometimes be unfair. And today, we're moving into a completely different sense hearing, and asking a fascinating question. Can a computer really hear you? By the end of this lesson, you'll understand what sound actually is from a scientific point of view, how AI systems can recognize and interpret sounds, real world examples of sound based AI applications, how to train your own AI recognition AI model, and the best practices for getting accurate results. So let's dive in. Now, what is sound? Before we understand how AI hears, we need to understand what sound is. Sound is a vibration that travels through air, water, and other materials. When something vibrates, like your vocal cords, a guitar string, or a speaker cone, it causes the air around it to move in waves. These waves have two important properties. One, frequency, how fast the vibration is happening, usually measured in hertz. This determines the pitch. And next is amplitude, how strong the vibration is, which determines the loudness. When sound reaches our ears, our brains process it through complex biological systems. But AI doesn't have ears or feelings, so how can it hear? Let's talk about that next. Now, how AI hears. Well, AI doesn't really listen like humans do. Instead, it uses a microphone to capture sound waves, turning them into digital data. This data is essentially a long list of numbers describing the changing air pressure over time, called a waveform. AI can then transform this waveform into something called a spectrogram, which is a visual representation of sound that shows how frequencies change over time. Once we have that, the AI can look for patterns in the sound, just like it looks for patterns in images. For example, the word yes has a distinctive waveform and frequency pattern. If the AI sees enough examples, it can recognize it later in new recordings. Now that we have that understood, let's look at where AI sound is actually used. Sound recognition AI is actually already part of our daily lives. And in this side, you can see some examples. The first one being voice assistants like Siri, Alexa, and Google Assistant. These systems wake up when they hear a wake word and can process spoken commands. The next one is music recognition apps like Sajam. These can identify a song within seconds by matching its audio fingerprint to a database. Now, smart home devices that responds to actions like claps, alarms, or spoken instructions. Last but not least, translation and accessibility tools like real-time captions for video calls or apps that help people with hearing impairments. The key here is that sound-based AI is everywhere and its applications are growing. Now, a mini demo. This is a demo that you can go ahead and pause and experience during your own time. Now, let's go through an understanding check. So, what helps AI hear? Well, AI uses a microphone and data to recognize sounds rather than physical ears like humans. Now, microphone and data. Well, this is when the microphone captures the vibrations in the air as digital data, which the AI can later then analyze for patterns. Ears and feelings. Humans use their sense of hearing and previous experiences to recognize sounds, not just data. And lastly, speakers. Speakers are used to output audio, not to recognize. Overall, AI can hear by analyzing the digital waveforms and spectrograms of sound, rather than using physical ears like humans. Let's train an AI with audio. Just like lesson two, in this lesson, you can go ahead and navigate to Teachable Machine. And instead of using the images feature, this time you can use the audio feature. Feel free to pause this slide and go ahead and go navigate to Teachable Machine and go ahead and test it out with the audio. This slide is supposed to help you with training the model. Here it shows that to collect audio samples, it's best that you have at least 10 plus samples of each sounds. This could include you audibly saying yes, no, or clapping. Make sure that you're using a clear voice and a consistent volume. Make sure you're speaking clearly and maintain a steady volume when recording your samples. Also, make sure your mic is on and that there is no background noise. Making sure that your microphone is working properly and recording in a quiet environment to avoid any unwanted background sounds. And also, this is a little tip. Make sure that you try saying whatever you're recording in different tones. That way, the AI can have a diverse set of examples, which will help it learn better. Remember from lesson 3, the more diverse the data is, the better answers you'll get. And this is just more model training and testing information. This following slide is for you to self-reflect on how your experience with teaching the machine went with audio. These are some questions you should keep in mind. Did it recognize all your sounds? Were there anything that caused mistakes? And how can we improve it? Make sure that you analyze the strengths and weaknesses of the AI's model performance and discuss actionable steps to improve the accuracy and reliability in recognizing the different sounds. Now, this following slide is to help you understand how your experience once again went with the teachable machine. Did your machine mix up yes and no? Sometimes AI could confuse similar sounding words due to not having enough training data to learn the distinct patterns. In another way, there could also have been insufficient training samples. AI models need a lot of diverse and comprehensive data set of voice recordings to accurately recognize different sounds. And lastly, another thing that could have gone wrong is maybe there was some background noise interference. Extraneous sounds in the recording environment can certainly make it harder for the AI to isolate and learn the target sounds. The key to improving the AI sound recognition is to make sure you have a well-curated, high-quality dataset with sufficient training samples and minimum background noise. Now, let's clear some myths. The first one, AI listens like a human. AI analyzes sound patterns mathematically. It doesn't really hear in a human sense. More voice samples doesn't matter. More high quality samples give the AI better accuracy. So, more voice samples does equal to smarter AI. Sound AI can't help people with disabilities. That one is completely false. Accessibility tools that are powered by AI help millions of people every single day. AI can hear sounds by recognizing patterns in audio clips. That is a big takeaway from today. And here's also things to remember. AI can recognize sounds by detecting patterns in audio clips, and microphones capture sound and convert it into digital data. Having variety in your training data is absolutely essential. And last but not least, testing and improving your model is an ongoing process. That's it for lesson 4. This one was a quick one. And now you can understand how AI can quote, hear, and interpret sounds. And you know how to build your own simple sound recognition model.